Hello and welcome to the CompTIA Cybersecurity Analyst, CSA+ Certification Study Guide. In this video, we will discuss Chapter 7.2 Vulnerability Scanning Methodologies. Please like, subscribe, and leave a comment. A methodology is a set of procedures. There are different procedures to follow when running a vulnerability scan. However, these vary depending on decisions that are made in advance. What should be scanned? There are several decisions that must be made prior to conducting a scan if it is to be impactful. Secure baseline scanning uses specific security frameworks as comparison benchmarks to identify weaknesses. These may be dictated by regulatory requirements and can play a role in the decisions. The prerequisite scanning decisions typically include determining what should be scanned and how and when it should be scanned. One of the first decisions before conducting a scan is to determine what should be scanned. It is axiomatic that critical infrastructure components should be scanned, such as operational technology, OT, which is using hardware and software to monitor and control physical processes, and the devices connected to the infrastructure that support these processes. Whereas a cybersecurity incident involving IT may be the theft of customer data, a successful attack on OT systems can be significantly more deadly and result in significant loss of life. A threat actor who can remotely manipulate the pressure in a pipeline so that it ruptures can inflict serious physical harm to a large number of persons. Beyond critical infrastructure components, often decisions must be made about which assets, devices, should be included in a vulnerability scan. This is because not all assets have the same value. Some assets are critical while others can be of lesser importance. To continuously scan low-value assets may take away from scanning and focusing on high-value assets. Determining what should be scanned first involves asset discovery. A higher level of asset discovery and identification is digital fingerprinting. Due to the large number of devices that are part of an organization today, identifying these, called asset discovery, is an important step in determining what should be scanned. However, in order to create this list of assets to be scanned, an asset inventory or listing of all significant assets needs to be consulted. For those organizations that maintain an up-to-date asset inventory through regular asset management, the asset inventory can be reviewed to identify the systems that should be scanned. However, what if there is no asset inventory available, or it is out of date so that it cannot be trusted as being accurate? Fortunately, most vulnerability scanning tools allow for an asset discovery inventory scan that only searches for devices attached to the network instead of conducting a full vulnerability scan that looks for vulnerabilities. Figure 7.2 shows the hardware asset management screen of a vulnerability scanner. Software assets can also be identified as shown in Figure 7.3. Asset discovery can identify devices that are connected electronically to the computer network. However, it is not uncommon for devices to be moved from one location to another without physical inventory records being updated. Thus, a device that appears in an asset discovery scan that must be physically accessed may no longer be in that originally recorded location. Is there a means for identifying assets in a more unique and granular fashion? The answer is yes. This involves both static device fingerprinting and dynamic network fingerprinting. Static device fingerprinting is the process of collecting information about a device's installed hardware and software configuration in order to create a unique identifier. These attributes can include the device's OS version, screen resolution, installed fonts, browser plugins, time zone, and much more. By combining these attributes, a unique fingerprint is created for each device, allowing it to be distinguished from others. This can be beneficial when performing an asset discovery for a vulnerability scan. Device fingerprinting is also used outside of cybersecurity. Website personalization, in which e-commerce sites recognize a returning user so as to offer customized recommendations or remember prior preferences, relies on device fingerprinting. It is also used by media streaming platforms and content providers to enforce digital rights management policies to prevent unauthorized access and distribution of copyrighted content. There are different techniques by which information for device fingerprinting can be gathered. User agent tracking involves collecting data about the user's browser, OS, and device by using JavaScript, server-side code, or browser plugins. Canvas fingerprinting uses JavaScript to draw an invisible image on the user's browser page, which creates a unique fingerprint based on the device's graphics capabilities. Cookies are small files stored on the user's device that can be used to track their activity across different websites and is usually combined with other techniques for digital fingerprinting. Web beacon tracking embeds a tiny and invisible HTML element called an inline frame, iframe, to track user behavior and collect data about the user's device and location. Audio and video fingerprinting involves using JavaScript or other tools to collect data about the device's audio and video hardware. However, threat actors also use device fingerprinting. Device fingerprints can be used for device spoofing. Threat actors can create a device fingerprint that mimics a legitimate device, making it difficult for security protections to distinguish between genuine users and imposters. A growing trend in digital fingerprinting is to not just fingerprint the static characteristics of a device, but also consider the dynamic usage of a device. Consider employees at an organization. They have unique characteristics and different ways by which they interact with the corporate network depending on their job role and responsibilities. A typical employee may interact with 100 or more networked applications daily while doing their job. And the integrations between these applications mean that there may be tens of thousands of interconnections and permissions shared across these 100 applications. Fingerprinting these day-to-day and even minute-by-minute interactions of users with their devices across the network can create a more robust digital fingerprint known as dynamic network fingerprinting. Some of the network data that can be captured to create this network fingerprint includes TCP options, ICMP requests, DHCP requests, IP time to live, TTL values, IP addresses and ID values, don't fragment bit setting, and window size. This dynamic network fingerprint can be used to both authenticate a user as being genuine while also identifying the abnormal behavior of a threat actor. Figure 7.4 illustrates a system that is used for unusual, anomalous traffic based on dynamic network fingerprinting. Dynamic network fingerprinting relies heavily on artificial intelligence, AI, using pre-trained workflow models. This allows for massive amounts of network data and hundreds of thousands or even millions of models to be managed. Critical anomalies can be immediately identified for security analysis. Another scanning decision involves how the assets should be scanned. 3 categories of options include active versus passive scanning, internal versus external scanning, and full network versus segmentation scanning. Active versus passive scanning. It is necessary for a vulnerability scan to collect data on the assets that are to be examined. For example, data such as the device name, IP address, OS version, installed software, and patches applied are all needed to then determine if there is a vulnerability. Extracting this data is called enumeration and is intended to create a picture of the endpoint and network. This process is called building map scans. There are 2 different approaches to gathering this data. Active scanning sends test traffic transmissions into the network and monitors the responses of the endpoints. Passive scanning, on the other hand, does not send any transmissions, but instead only listens for normal traffic to learn the needed information. A primary advantage of conducting active scanning over passive scanning is that active scanning can accelerate the collection of the data. It is not necessary to wait for normal network traffic to or from each asset to generate a complete profile of information. In addition, not all parts of a network may always be available, which can limit the ability to passively monitor traffic. Some active scanners can also immediately take action if a serious vulnerability is uncovered, such as blocking an open port, or even launch a simulated attack to observe the response. However, there are disadvantages to active scanning. These include smaller networks can become overloaded with high volumes of test traffic. Sending test traffic increases the risk of the endpoints malfunctioning if incompatible queries are sent. Some devices, such as Internet of Things, IoT devices, may not be able to perform their normal tasks while receiving and returning test traffic and could become overloaded. Many IoT devices are proprietary and may react differently to test traffic. Another option regarding how the assets should be scanned involves the vantage point of the scan. An internal vulnerability scan is performed from the vantage point inside the internal network. That is, It is launched and then conducted from inside the corporate network. An internal vulnerability scan typically has the primary benefit of identifying at-risk systems. An external vulnerability scan is performed from the vantage point outside the network. It targets specific IP addresses that are within the network to identify vulnerabilities. An external scan can also detect open ports and protocols. An external vulnerability scan is in some ways similar to a penetration test. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. We will see you on the next one.